Now we're going to see about the safety system of the refrigeration and air conditioning compressor. That is, how does the LP and HP cutout operate, stop the compressor, and then how does it restarts. Let's now understand the circuit first. We have a three-phase 440 volt supply, which is R, Y, and B. And through the direct online circuit breaker it goes to the stator of the induction motor, and we are taking any two-phase connection and connecting it to a step-down transformer. We don't require 440 volt supply for the control circuit, so we step it down to either 220 or 110 depending on the manufacturer through a step-down transformer. And let's now understand this control circuit, then it will be very easy to understand the operation. So let's now trace this line. So from the transformer it goes to a normally closed switch, which means during normal operation this switch remains closed. So we are using it for the LP cutout, and then it passes to the normally open contact, which means during operation, normal operation, this switch is always open, and we are using it for LP cut-in, and then it's in series with a normally closed contact again, which is always closed during normal operation, which you're going to use for HP cutout. And then this line passes on to a solenoid coil, which is called as sealing solenoid, and then it goes to the other end of the transformer, completing the circuit. This sealing solenoid has a link with the sealing contact, and then the direct online circuit breaker, it's all connected through this link. And you must observe one thing over here, that the sealing contact here is in parallel with the normally open switch of the LP cut-in. So now let's understand during normal operation the suction pressure and the discharge pressure are all normal, and let's see how the compressor works. When I put on the main breaker, which is in the switchboard, the supply comes here, and then this is suction pressure is okay. This is low pressure side, so the suction pressure is okay. So through this bellow, the suction pressure acts on this link and then closes this link or keeps this link closed against the spring pressure over here. So this contact remains closed. However, when you come to this, during normal operation with the same suction pressure, this link remains open because it's a normally open contact. You can see the difference. It is spring loaded and it is open. And when you come to the HP cutout, this is also normal. So the excess pressure beyond the normal pressure comes here, and then it tries to open here against the spring force. But since the pressure is normal, the spring force is more, and thus this keeps this link closed. And then it goes to the solenoid coil, and now the transformer circuit, the control circuit, is complete. However, since this normally open contact is open now, the supply coming from the transformer through this waits here, and there is no contact between these two. The link is open. So we got to complete the circuit to start the compressor. How that happens? For that, the suction pressure comes here and then acts on this link and then keeps it closed. Once this closes, the solenoid here gets energized. I'll explain once again. Since the suction pressure, that is the low pressure side connection, or the pressure is normal, it can enter through this bellow and then pushes this link and keeps it closed. Once this gets closed, the supply, the continuity or the circuit is complete, so that this solenoid gets energized and then it pulls the sealing contact down, thus closing the sealing contact, as well as the main breaker is closed, thus starting the motor for the fridge compressor or the AC compressor. So Now what happens? Let's see when let's say HP cutout operates. When the high pressure cutout operates, the excess pressure enters this bellow, and then we know that there is a spring force which is kept to which is adjusted to a particular pressure. Let's say that is 10 bar. Let's say the pressure exceeds 10 bar, the link opens against the spring pressure, thus the continuity of the circuit is broken, and then the solenoid de-energizes here, thus this sealing contact opens, and then the main breaker opens, thus the compressor stops. You got to manually reset the HP cutout. It doesn't reset automatically. So once you reset it, or the pressure becomes normal so that you rectified the fault, you reset it, then the LP side, the low pressure suction side, is normal. So the pressure comes, and then once again it closes this contact, and this contact closes. Again the solenoid energizes, closing this, and then closing the main breaker, thus the compressor starts. Now let's see what happens if the low pressure cutout operates, which means the suction side of the compressor is undergoing a vacuum or negative pressure, or which is set, let's say 1 bar is the normal suction pressure, or 1.5 bar is the normal suction pressure. Let's say we have set the LP cutout at 0.7 bar. Now let's say the pressure is going below 0.7 bar. Let's say it's 0.6 bar, which means the pressure on this bellow is less. So there is no sufficient gas pressure or the refrigerant pressure to keep this link closed. So the spring exerts a force and opens this link. Thus the continuity is interrupted, and once again the solenoid de-energizes, opening all the contacts on the breaker, thus the compressor stops. This is how the LP cutout works. Now let's understand what happens, or how the compressor restarts automatically. Now unlike HP cutout, you need not manually come and reset. Once the LP cutout is operated, let's say the suction pressure somehow becomes normal, so that what happens is the suction pressure, once it becomes normal, the gas pressure closes this link, and the gas pressure again closes this link, and the continuity is again brought into action, thus energizing the solenoid, closing the sealing contact and the main breaker, and the compressor starts. So this